So which of the following has the same number of valence electrons as sulfur? Okay, so the way to do this is just to look in your periodic table. So go back to your periodic table. This lesson is all about periodic tables. And you look for sulfur, and then you pick whichever one of these is in the same group, same column as sulfur, and that will have the same number of valence electrons. And if you look, it can't be sodium or magnesium, you know that for sure. So it's between these two now, phosphorus and oxygen. If you look at it, look at your periodic table, hopefully you see it, and it's oxygen. Okay? So oxygen will sit above sulfur, and so they must have the same number of valence electrons. Okay? Which of the following has the same number of valence electrons as carbon? So again, we're going to do the same thing here. We're going to look at which one of these elements is in the same group or column as carbon. So we know it's not nitrogen or neon, so it's between boron and tin. But boron is actually not in the same group, so it must be tin. Okay, so just look on your periodic table and you'll see these answers pop up. If you don't get it, just go back, just pause for a second, look at your periodic table and see if you can catch up to where we are, and then hopefully you understand why they have the same number of valence electrons, because they're in the same group. It sort of defines what a group is. Okay, which of the following is a real chemical compound? And by real, what we mean here is which one can actually physically exist. Some of these cannot possibly happen. Okay, so let's have a look. NaO. Okay, NaO, Na can give away 1 electron. Oxygen requires 2 electrons. So you would need 2 sodium atoms to satisfy 1 oxygen atom. So you can see this one can't happen, okay, because there's not enough electrons to be given away. What about B, MgO2? So oxygen again needs 2 electrons. So 2 oxygen atoms would need 4 electrons. Magnesium can give away 2 electrons. So we're short 2 electrons. So again, there's not enough electrons, so B is not true. Calcium trichloride. Well, calcium can give away 2 electrons, but chlorine needs 1 electron. But 3 chlorine atoms would need 3 electrons. So we're again 1 electron short. It's not D. That leaves us with, C. Obviously it must be the answer, but we can prove it. Potassium can give away 1 electron. Fluorine requires 1 electron, so they're both happy. Potassium will give away its electron, fluorine will take it, and so they'll form an ionic compound. So C is the correct answer.